Okay, for the next example, we should find the inverse of the following function and state its domain and range. So for this function, we have that f of x equals to x power 3 minus 1. So to find the inverse function, we use the composite function formula. So f of f inverse of x equals to x. So then we substitute the inside function, which is the f inverse, into the outside function, which is x power 3 minus 1 equals to x. Then we rearrange to find the inverse function. We have f inverse power 3 equals to x plus 1, and f inverse of x equals to cube root of x plus 1. Okay, so the domain of f inverse is equal to range of f, which is minus infinity to infinity. Range of f inverse, it is the same to the domain of f, which is negative infinity to infinity. So for the next example, we need to find the inverse of this function and then state its domain and range. So this function is fx equals to 1 minus square root of 5 minus x. So to find the inverse function, we use the composite function formula. So f of f inverse of x equals to x. Then we substitute the inverse function inside the function here, which is 1 minus square root of 5 minus f inverse of x equals to x. Then we rearrange this one. We should have 5 minus f inverse of x equals to 1 minus x. Then 5 minus f inverse of x equals to 1 minus x square. And then we have f inverse of x equals to 5 minus 1 minus x squared. So this is the inverse of the function. So now the domain of the inverse function is the range of the function, which is negative infinity until 1, and then range of the inverse function is equal to domain of the function, which is negative infinity until 5. Alright, for the next example, we determine whether the inverse function exists or not by using algebraic or graphical method, hence find its inverse if it exists. So for this function, we can use the algebraic method to find whether it has an inverse or not. So we let fx1 equals to fx2, and then we have 2x1 plus 3 equals to 2x2 plus 3, and then we can cancel this out, and then we're left with 2x1 equals to 2x2, and then x1 is equals to x2. Right, so since x1 equals to x2, we say that fx is a 1-to-1 function, therefore f inverse exists. Alright, and to find its inverse, as usual, we use the composite function formula. So f of f inverse of x equals to x. So we just substitute the inverse function in the function of fx. So we have 2f inverse x plus 3 equals to x. Then we rearrange to have f inverse of x equals to x minus 3 over 2. Okay, next we need to determine whether the inverse function exists or not by using algebraic or graphical method. Hence, find its inverse if exists. So for this function, we can use the algebraic method to find whether it has an inverse or not. So we let fx of 1 equals to fx2, and then we have that x1 square root of x1 plus 3 equals to square root of x2 plus 3. Okay, and then we square both sides to cancel out the surds. So we're left with x1 plus 3 equals to x2 plus 3. And then we can cancel out these 3's. And then we're left with x1 equals to x2. Therefore, we know that since x1 equals to x2, fx is a one-to-one function. So f inverse exists. So now we know that f inverse exists. We can now find the f inverse. So we can use the composite function formula f of f inverse equals to x. Then we substitute the f inverse in the function. So we have f of f inverse x plus 3. Don't forget the square root here equals to x. Then we rearrange. We'll have f inverse plus 3 equals to x squared, and then f inverse equals to x squared minus 3 for x greater than or equals to 0.